Hi, in this video, I'm going to talk about the confidence interval for the two proportion. So same thing as the confidence interval for the mean. From the population, we want to know the population mean or the population proportion. In this case, we are interested in the population proportion P. But since we don't have the population data, we get the sample, and from the sample, we calculate the sample proportion P hat. But this is a sample, the sample statistic. That is a one specific value that is a point estimator. But in many cases, we expect that this P hat is not the same as a population proportion P. But based on the sampling distribution, we know that this sample proportion P hat follows normal distribution when n times P hat is greater than 5 and n times 1 minus P hat is greater than 5. If this condition is satisfied, then we can say that this P hat is approximately normally distributed with the mean equals P and the standard deviation is square root P times 1 minus P over N. Okay. So that being said, based on the sampling distribution, we can constant the confidence interval because that this single specific value is not enough to infer the population parameter, this proportion. So that's why we want to have the interval estimation. So let's solve the question. The first question is following. If n, the sample size is equal to 200 and x equals 40, and we want to construct the 90% confidence interval for the population proportion. So sample proportion P hat is x over n. So that is a 40 over 200. So 40 over 200 is a 0.2. So 20%. Then we go one step further. We want to construct the confidence interval, but you need to check the condition. N times P hat is a 200 times a 0.2 is a 40, which is greater than 5. N times 1 minus P hat, that is 200 times 0.8, that is a 160, which is greater than 5. And we can say this P hat follows normal distribution. And based on that, we want to construct a 90% confidence interval. Since we can use a normal distribution, the formula is following. So P hat plus minus margin of error, where this margin of error is Z alpha over 2, same as a confidence interval for the mean, times standard error. And the standard error, the formula is square root P hat times 1 minus P hat over N. Okay. 90% confidence interval, well, this one is a Z 0.055% because alpha is 100 minus 90%, that is a 10%. And then alpha over 2 is a 5%. That's why I put the Z 0.05. Or you can visualize a standard normal. So this is standard normal. And here's a mean equals 0. And this is a 90%. What we try to find is a here, Z 0.05. Okay? In order to find this one, you need to use the Excel or the TID4 or the table, but let me show you how to use the Excel to find this Z critical value. So put the equality, norm inverse, 0.95, mean equals 0, standard deviation equals 1. That is a 1.645 up to 3 decimal places. If you put the 0.05, so let me show you just in case, norm inverse, 0.05, mean equals 0, standard deviation equals 1, then you will get the exactly same number, but the opposite side, the negative side. So this is a negative Z 0.05. So that's why when I put the 0.05, I get this one, negative 1.645. But when I put the 0.95, so that means that this is a 5% and this is 90%. Together is a 95%. That gives me this positive critical value. And the critical value has to be positive. So if you have the negative value, then you just need to drop the sign. Okay? So then this margin of error is 1.645 times square root. This P hat is a 0.2 and 1 minus 0.2 is a 0.8 divided by sample size 200. So let me calculate this margin of error. So 1.645 times square root SQRT, 0.2 times 0.8 divided by 200. Then I got the margin of error 0.0465. So this p hat 0.2 minus this margin of error gives me the lower bound, and 0.2 plus this margin of error gives me upper bound. So p hat minus margin of error, the lower bound is 0.15, 0.1535 up to 4 decimal places, and then p hat plus margin of error is 0.2465. So then the interpretation is we are 90% confident that the true population proportion would be located between the 15.35% and 24.65%. Okay. Now let's look at the question number 2. A cell phone provider has the business objective of wanting to estimate the proportion, the true proportion of subscribers who would upgrade to a new cell phone with the improved feature if it were made available at a substantially reduced cost. Data are collected from a random sample of the 500 subscribers. That means that n equals 500. And then the results indicate that 100 of subscribers would upgrade to a new cell phone. So x equals 100. So from there, you can calculate the p hat, which is x over n, 100 over 500. That's a 1 over 5, or that's a 0.2, okay? And then you can check n times p hat is greater than 5, n times 1 minus p hat is greater than 5. But of course, this question satisfies the condition, okay? 100 times a 0.2, sorry, the 500, sample size is 500. 500 times 0.2 is 100, which is greater than 5. N times 1 minus p hat is 500 times a 0.8, which is a 400. So both of them greater than 5. But you know what? If this condition is not satisfied, then we cannot construct the confidence interval. So then you can say that almost every question that you solve satisfy this condition. So you may want to skip this condition, okay? But if you're solving the FRQ, you need to write down every single detail. But when you just need to find the number, then you don't need to check the condition for the confidence interval for the true proportion, okay? Now, first question A, construct a 95% confidence interval. So p hat plus minus margin of error, and this margin of error is z.025 times square root p hat times 1 minus p hat over n. And if you watch the video confidence interval for the mean, you know that z.025, that's a 1.96. But let me show you just in case. So put the equality, norm inverse 0.975, mean equals 0, standard deviation equals 1, then up to 3 decimal places, it gives you the 1.950, right? Up to 3 decimal places, sorry, the 1.96. And if you put 0.025, so norm inverse 0.025, mean equals 0, standard deviation equals 1, then it gives you the exactly same number, but with a different sign, okay? And plus square root 0.2 times 0.8 over the sample size 500. So let me calculate the margin of error, which is 1.96 times square root 0.2 times 0.8 over sample size 500. So that margin of error is a 0.035 something. So p hat 0.2 minus 0.2 minus this margin of error gives me the lower bound 0.2 plus this margin of error gives me the upper bound. So margin of error was 0.035, and we just found the lower bound, the upper bound. Lower bound is 0.61649, and the upper bound is 0.2351. So then we can interpret as we are 95% confident that true population proportion of the subscribers that would upgrade to a new cell phone at a leading cost would be located between the 16.49% and 23.54%. Now you do the exactly same thing, but we have 99%. So the confidence level is 99%. And we just need to change this Z critical value, right? So let me copy and paste. And then I'm going to change this Z critical value. So let me show you. So this one now 99%. Then we have Z 0.005. So why is it 0.005? 100 minus 99% is a 1%, and you divide it by 2. So 1% divided by 2, that's the alpha over 2 is 0.5%. That's why the 0.005%. Again, if you're not clear this part, then you need to study the sampling distribution. Okay. So let me find this Z critical value. Put the equality, norm inverse. But let me find the negative one, but I'm going to drop the sign. 0.005, mean equals 0, standard deviation equals 1. Then I have a negative 2.576. So this is 2.576, up to three decimal places, but I dropped the sign. Okay. Then I need to calculate this margin of error. So 2.576 times square root 0.2 times 0.8 divided by 500. Then the margin of error is 0.046 something. So 0.2 minus this margin of error, that gives me the lower bound. That's a 0.1539. And 0.2 plus this margin of error gives me the upper bound. So the lower bound is 0.1539. Upper bound is a 0.2461. Okay. So then the interpretation is we are 99% confident that true population proportion will be located between the 15.39% and 24.61%. And when you compare with the 95% confidence interval, what do you see? When you raise the confidence level from the 95% to the 99%, confidence interval become wider. Okay, so you raise the confidence level, then you're gonna have the wider confidence interval. If you have a narrower confidence interval, that means that somewhere you made a mistake. All right, so let me stop here.